Hi folks, this is Conundrum again. This time we're going to talk about the horizon. This is how we learned at school that light travels in straight lines and that the horizon is the maximum distance we're able to see, right? Wrong. All we learned is fine, except that nothing is stopping us from seeing objects that are thousands of kilometers away from the horizon limit. For example, the sun, the moon, ships and buildings and aeroplanes beyond the horizon. So what is the angle of elevation of the horizon? If we take a camera and we level it, it means that we're aligning it with the water level at our position. If the earth is curving, it means that the water and the ground is curving away from us. That means that in order for us to point the camera at the horizon, we have to also point our camera down, like this, thus moving it away from water level in a negative inclination. So the horizon is never level, it is always negative in the global sphere model. The same is true for the flat Earth. Since the Earth is flat, it means that at the cutoff point, called the horizon, we have to point our camera down towards the ground, thus breaking away from the water level into a negative inclination. In the concave Earth model, although theoretically possible to have a positive inclination angle to the horizon, Navy data indicates that it is in reality negative. So tests should be run to verify the Navy data as correct. So for the purposes of this video and until new data arises to the contrary, I'm going to assume that all models, including the concave Earth model, show negative inclination angles to the horizon. Watching one of the flat Earth videos, I came across mention of lighthouses and how they prove that the Earth is flat. Let's watch one of these clips and try and catch the insinuations that they're trying to implant in our brains and the outright lies that they claim for truth. So I looked into lighthouses and how ships navigate by lighthouses at night. And I came across another video from the US Navy that shows how navigators navigate ships at night using lighthouses. In the video, it showed how the light from a lighthouse appears out of nowhere in the middle of the night, just on the edge of the horizon. And this is also how we learned at school that the Earth's bulge is what causes the obstruction that we call horizon. At each position where we're at, the water level is at 0 degrees. This is how we measure things. But the horizon is in the negative degrees, not 0. The horizon cannot be 0 because you have to look down towards the Earth in order to see it. This is true always for the global sphere theory, the flat Earth theory, and the concave theory, because the observer has to look down. So, looking towards the horizon, you always have a negative elevation of the horizon. But the Navy noticed that light from lighthouses behind the horizon reaches them much lower on the ship than theory anticipated. They explained this phenomenon as being caused by atmospheric refraction, the bending of light. How do they envision it? Like this. Based on the Bowditch Naval Manual, light travels in an arc with a function relating its height above ground to the square of the curved distance away from the source. So, depending on the distance you have from the source, that will determine how high you have to be in order to see the light. So they determine that light reaches much further than without refraction. So instead of being here to see the light, you can be down here and still see the light from the lighthouse. Also, they notice that light reaches much lower than without refraction. Instead of having to be up here in order to see the light, if it came in straight, you can be down here and still see the light. So the Bowditch Naval Manual shows that light bends both ways, behind the horizon and in front of the horizon. It's a two-way bending of light with the horizon in the middle. That's where the horizon, that is where if you had a theodolite and you looked at the light coming from the lighthouse, it would be at 0 inclination. Here, the light is at negative elevation. If you are standing here, on the other hand, the light would be at a positive elevation. You have to turn your head up in order to see it. So for all intents and purposes, as they say, the Navy does not really care much as to how exactly light bends. They are more into navigation, destroying targets, controlling the line of sight. So they are more interested in easy, practical and quick ways of doing that. This is also why they consider the horizon a 15 feet elevated place, because they know that below 15 feet everything is strange at the horizon. So refraction, the global Earth theory claims, results in much smaller declination angles to the horizon. In theory, the light, if it traveled in straight lines, should reach us up here with such a large declination angle to the horizon. Whereas now, light reaching us down here, this results in a much smaller declination angle. This diagram is to scale. This is the true light path with refraction in the global sphere model. The green light paths are to scale and are plotted from the Bowditch Naval Manual light function. This is an exact representation of how the Navy considers things. So even though the Navy publishes information like this in their video, there are no straight lines in distances. The distances are in nautical miles on the surface of the Earth, and the light path is also in a curved arc around the Earth, just like this. This is a correct representation of what the Navy considers as an approximation of reality. So remember, the Navy indirectly admits that light is bending. The Navy horizon is 15 feet above sea level for a reason. And when two horizons meet, the horizon of the ship with the horizon of the lighthouse, you can easily see much further than you thought, as long as light is intense enough to reach you. Lighthouses. Each lighthouse has a different rating and intensity. This is an example. This lighthouse has a range of 30 nautical miles. The intensity is measured in candela or lumens.